This video is for section 13-3, the sum of an arithmetic progression. An arithmetic progression, also called sequence, is a list of numbers. That list of numbers is separated by commas. If you replace the commas with addition symbols, that creates a series of numbers instead of a sequence. A series represents the sum of the terms in a sequence. For example, 4, 5, 9, 17 is a sequence. The related series is 4 plus 5 plus 9 plus 17. We could find that sum and get an answer. Do you remember how we created an expression for the nth term of an arithmetic sequence? It was this formula right here. Let's create an expression for the sum of an arithmetic sequence. To generate that formula, we start with this step here. The sum of n terms in an arithmetic sequence is equal to the first term plus the second term plus the third term, and so on until you reach the nth term. And right here you recognize the formula for the nth term. To simplify this up so the formula is not so difficult, we can use some algebra steps. If you rewrite the series and replace the last term with a sub n instead of this more complicated formula, now it looks like this. Next step, rewrite the series in reverse order. So now it looks like this. If you add the original statement together and this statement right here, on the left side of the equals, it will be 2 times s sub n, and on the right side, it will look like this. Because this expression appears n times, we could shorten the expression to this. And then dividing both sides by the number 2 to get s sub n alone, we get this final formula that finds the sum of the terms of an arithmetic progression. In that formula, if you replace the a sub n with our formula from the other day, here is another version of that same formula. Let's take a look at the difference between them to know when to apply the two formula. This one here looks like it would be a good one to use if you have a number to replace the n with, if you know the number of terms. And you would want to have a value to fill in for a. You would want to know the first term. And you need to know the common difference between the terms. Let's look at that previous one though. When would you use this formula to find the sum of terms in an arithmetic sequence? You would need to know the number of terms you're summing, and the first term and the last term. So that's how the formulas are different. This one finds the sum from knowing the first and last terms. This formula here finds the sum from knowing the first term and knowing the common difference between terms. Here's an example problem. Find the sum of 18 terms of this arithmetic progression. Notice that the difference between terms is 3. So D equals 3. We want to find the sum of 18 terms. In symbols, that's S sub 18. Well, which formula should we use if we know the first term and we know the value of D? We want to use the second formula, the one that's on the screen right now. So you replace n with 18. The letter A is the first term, which is 4. Again, the n is 18. And the number D is a 3 in our sequence. Then figure out this answer. 18 divided by 2 makes 9. And then inside the bracket, let's see what that makes. 2 times 4 is 8. 18 minus 1 is 17. 17 times 3 is 51. And 8 plus 51 is 59. Then 9 times 59. The answer is 531. We can use the Greek letter sigma to write a series. Here's an example. This series, 3 plus 6 plus 9 plus 12, and so on all the way to 24, can be expressed with these symbols. So notice the sigma symbol, and then right down here in the bottom corner of that, or even underneath, you say n equals 1, and then in the upper corner, or right above, you say 8. That's telling us that the number of terms is running from 1 through 8. And then over here on the side of the symbol is the mathematical formula that generates each of the terms. In this case, it's 3 times n. If n was 1, what does 3 times n output? 3 times 1 makes 3. That's the first term. What if n was 2? Then what's 3n then? 3 times 2 is 6. What if n was 8, the last number that we're told to use? 3 times 8 is 24. So these symbols here are an alternate way of writing out a series without having to actually list every number out in that series. The way that you speak this out loud, when you see the sigma symbol, you say the summation from 1 to 8 of 3n. What this means is add all the terms obtained from the formula 3n by replacing n with the consecutive integers from 1 to 8. We're asked, what is the value of this? Well, to find the answer, we would add up the numbers in that list. You could do it in your head, or you could take a calculator and type 3 plus 6 plus 9, and so on until you reach 24. And the result is 108. So a little bit of review. The summation symbol in algebra is this right here. This is a Greek letter, sigma. The word summand refers to the general term written to the right of the summation symbol. In our example, the summand was the 3n. The index refers to the variable that's written under the summation symbol. In our example, our index is n. Here's an example problem. Write the sum from 1 to 5 of 4k in expanded form, and then evaluate. So start with the very first number you're told to use for the index, which is 1, and replace the k with 1 in the summand. 4 times 1 is 4. Then work your way upward. Now replace it with a 2. 4 times 2 is 8. Now replace the k with 3. 4 times 3 is 12. Then replace it with 4. That makes 16. Then replace it with 5. That makes 20. You stop at 5 because in the symbol it tells us to stop at 5. We're summing up this formula starting at 1 and stopping when we reach 5 for k. To evaluate, you add this up in your head or on a calculator. The result is 60. Next example, write the first 3 terms of an arithmetic progression where this should say n equals 7, L equals 7, and S sub n equals 25.5. Earlier in the lesson, instead of using the letter L to represent the last term in a sequence, we used A sub n. We have a formula involving the sum of a sequence when we know n and we know the last term. It looks like this. In place of S sub n, we can fill in 25.5. In place of n, fill in 7. Our first term is unknown, but the last term we are told is 7. We can solve this for a, and by doing that, we'll discover the first term in our sequence. First, we might multiply by 2 on both sides, getting 51 is equal to 7 times a plus 7. Next, we can do the distributive property. 51 equals 7a plus 49. Then subtract 49, getting 2 is equal to 7a. Therefore, a is equal to 2/7. We now know the first number in our list, but we can't get the second or third term without knowing the value of d, the common difference. So now let's find that. We had another formula about the sum, but it had the letter d in it. S sub n equals n over 2 times 2a plus n minus 1 times d. In place of s sub n, we can put in 25.5, n is 7, and then 2 times a would be 4/7. Again, n is 7, and it's the letter d that we don't know. Now let's solve this. We could multiply both sides by 2, getting 51 equals 7 times 4/7 plus 6d. Then distribute. 51 is equal to 4 plus 42d. Subtract 4 from both sides. 47 equals 42d. And divide by 42. We get 47 over 42. We know the first term is 2/7, and we know the common difference that we can add to get the next term. Let's put the answer right up here. The first number is 2/7. Then take a calculator and go 2/7 plus 47 over 42. We get 59 over 42. Then add 47 over 42 to that, and we get 106 over 42, which reduces to 53 over 21. Here are the first 3 numbers in the list. Final example. Use summation notation to write out this series of numbers. If it bothers you that there's minus signs, think of it as 1 plus -1 plus -3 plus -5. Maybe that looks more like a sum to you. We're asked to use summation notation, so you write a sigma symbol, then choose any variable you'd like to be the index. I'm going to choose the letter n, and I'm going to count that from 1 to 4 because there are 4 terms in our series. Now on the side, we need to create a formula that would output all of those terms as you plug in different numbers for n. For instance, when n is 1, we would like the output to be 1. But when n is 2, we would like the output to be -1. When n is 3, we want it to output -3. And when n is 4, we want it to output -5. What kind of math formula would do this? Well, remember, this is an arithmetic progression, so there is a common difference from term to term. In this case, it's subtracting 2 every time. So let's create a formula for the general term. The other day, we used the symbol t sub n for that. It was equal to the first term plus n minus 1 times d. Our first term is 1, and our value of d is -2. Let's simplify this. This makes 1 minus 2n plus 2, which is 3 minus 2n. That's our general term, and that's what goes on the side of the sigma notation. Here is our answer to this example problem. Let's summarize the lesson. We discussed how to find the sum of a series, which is the same thing as a sequence, but the commas are replaced with adding symbols. There are 2 basic formulas that you can use. Here is the first one, and here is the other one. You decide which formula you use depending upon what information you know about the series.